Welcome to my alternative assignment 3. Today we are covering lessons 14 through 20, diving into lists, sorting, dictionaries, file readings, and exception handling. But instead of just talking about the theory, we're going to apply these concepts to our real, everyday lives. Well, more specifically, programs that solve something in my daily life. First up, lesson 14, the video game backlog. Right now, me and my younger brother are sharing a room because his is being renovated. Space and screen time are tight. So to make sure we never waste time deciding what to play, we're going to build a digital backlog using lists. A list in Python is exactly what it sounds like. A container that holds multiple items. We can use methods like .append to add new games, or .pop to remove games once we beat it. Even cooler, we use nested lists to save inside our lists that hold the title, the genre, and whether or not it's multiplayer. So let's go over to the full code. At the very top, on lines 2 through 6, we set up our starting log. This is our nested list. Each game is stored as its own mini list inside the main list. Moving down to line 8, we start using our list methods. So me and my brother bought Mario Kart, so we .append to instantly drop it back to our backlog list. Then, let's say we thought Skyrim was too long and boring, so we deleted it, or we finished the game. So we used .pop to remove it from our nested list. Down on line 17, by typing 0, semicolon 3, we grab the top 3 games from our list, so we have a quick queue. And finally, down lines 20 through 23 is just a simple for loop that unpacks the title, the genre, and now I will run the code so you can see it. So it says we decided to skip Skyrim, which is line 13, and then the for loop is the rest. Now let's go on with the next lesson. Moving right into lesson 15, let's upgrade the video game backlog. The problem with the backlog right now is getting huge. When me and my brother and I have an hour free time, we don't want to scroll through all the games we have since many of them don't meet our needs. Like we have a ton of single player games that we obviously can't play. So what we need is a filter. Normally to filter a list, you create a blank space, write a for loop, add an if statement, and append the results. But Python gives us a superpower called list comprehension. It lets us squish all the logic into a single line of code. It has 3 parts: the interval, what we're looking at, the transform, what we want to keep, and the filter, the rule for keeping it. So let's go to the code. On lines 2 through 8, just set up our expanded nested list of games again. As you can see, it's been updated and changed slightly to, adjust to this new lesson. But the real magic and the focus of this lesson happens right here at line 11. The single line of code in our list comprehension. It reads left to right. Keep the game title, game in backlog if multiplayer is true. In just one line, Python loops through the database, ignores the single player games, and creates a clean list of co-op games. And then lines 13 and 14 print out that new list. On line 17, we do the same exact comprehension trick, but this time our filter checks if the genre is equal to RPG. Lines 19 and 20 print that out and returns RPG games, which is redundant. But anywho, let's see the code run. So it gave us back Minecraft, Halo, and Overcooked for co-op games, which is true. And then down here, it gave us The Witcher 3 and Persona 5 for RNGs, which you can see are. So now let's go on to the next lesson. For lesson 16, we're moving to a new section, my physical media collection. I collect vinyl records and my shelf is a complete mess. I can never find the album I want and they're completely out of chronological order. Today we're fixing that with the sort and search algorithm. We aren't just going to use Python's basic .sort tool. We're going to write a custom insertion sort. Think of it like holding a hand of playing cards. You take the next unsorted card, figure out exactly where it goes in your hand, and insert it. We're also going to use the SYS module so we can type a search term straight into our command line. Our program will use linear search to check every record on the shelf one by one until it finds it. So let's go to the code. Let's break down the script from top to bottom. At the very top on line 1, we import SYS to get access to the command line argument. Lines 4 through 10 hold our unsorted vinyl collection as a nested list. 13 through 21 act as our linear search. If I type an album name, when I run the script, systems.arg1 grabs it. We then loop through every record to see if it matches our search terms. And if it does, it will show us the vinyl and when it was released. And if not, then it's not found on the shelf. Now for the main event. Lines 26 through 35 is our custom insertion sort. This is the core of the lesson. The loop looks at the release year of an album, compares it to the album before using a while loop, and literally shifts them backwards until the current album finds its perfect chronological spot. Finally, lines 38 and 39 simply loop through and print out our newly sorted shelf. So let's see this run. Let's go to here. Let's type in Thriller. Now it takes a little bit to load because it's slow. Alright, so I typed in Thriller. The system found it and told us it was released in 1982. And then we can see the program also organized it by its date, because before it was completely unordered and now it's chronologically ordered. Now if we do this again, but type in an album that is not in it, like actually I'm gonna mistype it. I'm gonna put in Thrills. Okay, it says the record was not found on the shelf, and it still reorganized it chronologically. So let's go to the next lesson. Continuing right along to lesson 17, our vinyl records are now sorted chronologically, but a simple list isn't power enough anymore. What if I want to know the pressing color of a record, the RPM speed, or its exact condition? To store that much data, we need dictionaries. Unlike a list, where you have to remember index numbers, a dictionary uses key-value pairs. You look up a word, the key, and it gives you the definition, the value. Even better, we can build a nested dictionary, which is a dictionary inside a dictionary. So let's go on to the code to demonstrate this. Let's look at the whole program. Lines 2 through 6 are our nested dictionaries. Notice the main keys are the album titles, and attached the values are mini dictionaries holding the artist's name, the color, and the RPM. To use this data, lines 10 and 11 use a basic for loop with the .keys method to print out a clean menu of the albums we own. But the most important part of this script is down lines 16 through 22. By using the .items method for our loop in our for loop, we unpack both the album titles and its inner metadata dictionary at the same time. On lines 17 and 18, we use the .get method to safely pull out specific artists and color from that inner dictionary so we can print a highly detailed inventory report at the bottom. So now let's see this run. As you can see here, the available albums are current, discovery, random access memories. And here's the detailed report, gives us the album, the artist, and the pressing. So now let's go on to the next lesson. Now let's switch gears for lesson 18 and look at the final section, the movie night curator. For family movie nights, no one can agree on what to watch. So I downloaded a massive CSV dataset of the top 100 movies of all time from Kaggle, which has free to use files for all sorts of projects. Our job is to build a program that reads this external file and prints out a clean, readable menu. To do this, we use the with statement to open our file. It's like a smart door. It automatically closes the file behind us so the computer memory doesn't get overloaded. We use the .read lines to grab the text and string formatting with double placeholders to force the text into two perfectly straight columns. So now let's go on to the code. On line 2 and 4, we have the with open statement to create a safe connection to our top 100 movie file, and we have a .read lines to read the file and put that data into this list variable. Next, on lines 9 through 13, we have our tabular formatting template and print out a nice custom header. The big focus here is the loop on lines 17 through 25. We loop through the first 9 movies. On line 18, We then use the dot strip to rip off invisible new line characters that the file has. We then slice the data into a rank and a raw string. Finally, on lines 25, we push those variables into the template using the dot format so it prints a nice aligned table. So let's see the code run. As you can see here, we have the 1 through 9. So I've heard all of these except the Shawshank's Redemption, the 12 Angry Men, Schrodinger's List, Pulp Fiction, until this project, but it's bizarre to me that these are the top 9 and I've never heard of them. So yeah, that's lesson 18. Now on to 19. Building on that in lesson 19, we saw the raw, comma separated data can be really annoying to read. The biggest problem, what happens if a movie genre has a comma inside of it, like bracket, crime, comma, drama? If you try to split the string on commas, Python will accidentally chop up the genre in half. So to prep for some real world data analytics, which is very similar to what you do in Excel. It's the same type of logic, which is cool. I mean, irrelevant, but yeah. So we need a better tool. Enter the CSV module and its ultimate weapon, the dict reader. It reads the very first row of the file, sees the column names, and automatically turns every row into a dictionary where the column names are the keys. So now let's go on to the code. Let's walk through the script. Line 1 imports the CSV module. Lines 3 and 4 set up a couple of variables that we'll use as counters for some math. And the core of the lesson starts at line 6. We safely open our file with the with statement, and then on line 8, we use the CSV dict reader so we don't have to guess index numbers anymore. On lines 14 through 16, I can ask for the title and genre just by its name instead of the index number. And then we simply use an if statement on line 19 to count if the movie is a genre using the genre list. And we have another if statement on line 23 to print the movie if it was released in 1994, which, fun fact, is considered the best year in film. And then lines 26 and 27 print out our math. So let's see it in action. So we can see it got all these movies that were made in that legendary year. And then out of the top 100 movies, 70 of them are dramas. So now let's go on to the final lesson. We need to address one glaring issue. Our programs are fragile. Last semester, for instance, in my social informatics class, I had an assignment that showed how reliant we are on technology and how incredibly frustrating it is when a system breaks. If I build a movie searcher and ask someone to type in a release year, what happens if they accidentally type in the word 2000 instead of the number 2000? The whole program crashes with a value error. We're going to fix that with using exception handling. We will wrap our risky code in a try block. If an error happens, we can catch it with an except block so the program stays alive. We are even going to write a custom error to stop users from entering a year before movies were even invented. So let's go to the code. Now let's look at our final crash-proof script. On lines 4 and 5, I defined our custom exception called movie too old error. Line 7 then starts our search function. And then line 8 is our while true loop so the user can keep on searching until they decide to quit on line 9. The critical part of the lesson starts on line 13 with our try block. We attempt to convert the user's input into an integer. If they type in a word, it causes an error. As you can see down here, error, please enter a valid number. And then if we type in 1800, our if statement on line 17 triggers the raise command, manually throwing our custom movie too old error, which says movies didn't exist back then, try newer year. Fun fact, first motion picture was created in 1888, around 1888. And then lines 21 through 25 opens the CSV and prints the movies if it finds a match. To stop the program from crashing, we have our except blocks, which I've already explained, with the value error being you typed in the word instead of the actual digits. And then there's the to old error, which is our custom one. And then finally, on line 35 and 36 is the finally block. This executes no matter what happens. It logs the search attempt every single time. And with that, our movie searcher is completely crash proof. So let's demonstrate it. Okay, movie night search engine. Enter a year to find top movie or type quit. So let's search up 1975. It found One Flew Over the Cooked Nest, which is a drama. Let's type in. I'm pretty sure this year doesn't have one. Oh, no, it did. It was the ones that around this year don't have one. So it says no top 100 movies. And then, oops, let's type in 2000. Please enter a valid number. Now, let's watch a movie from 1820. Movies didn't exist back then. Try a newer year. And finally, we can quit. Thanks for watching, and I want to thank our professor and the TAs for the semester. I did take a introduction to computer science course in high school. This was a great refresher, and I feel prepared for part 2 of this class. Again, thank you for watching, and I hope you guys have a great rest of your summer. Bye.